Okay, so today we're going to cover section 4 of chapter 5, and we're going to learn about isosceles and equilateral triangles. The first thing we need to do before we can even get into any of the theorems is learn about the parts of an isosceles triangle. Now, we learned prior to this that an isosceles triangle has two congruent sides, and those two congruent sides are called the legs of the triangle. So that you'll be given markings on the triangle indicating that these two legs are congruent. The third side of the triangle that does not have a congruency mark on it is called the base of your triangle. Now, the isosceles triangle may not always be sitting on its base. Just know that the base is going to be the side that's different than the two congruent legs. And then the angle that is across from that base side is called your vertex angle. Now, what we're going to see coming up is a theorem that's going to tell us that if we have two congruent sides, then the two angles that are opposite to those congruent sides, these are called the base angles, and they're also going to be congruent angles. So the legs are going to be the congruent sides, and then the angles opposite those congruent sides are going to be called the base angles. Now, sometimes your picture might be sitting sideways or even upside down. And notice if you have congruency marks here, these are the legs, and this would be the base. So again, the base doesn't always have to be the bottom. It could be the top, or it could be the side. What you look for are the congruency marks on the legs. So our first theorem is called the base angles theorem. And this just states that if two sides of a triangle are congruent, then the angles opposite them are also congruent. So once you're given that these two legs are congruent, AB congruent to AC, then we can conclude that the angles across from them or opposite to them, so these down here, are going to be congruent as well. So these will be your congruent base angles, so we can say that angle B is congruent to angle C. So these are going to be the angles that are opposite the congruent sides. The next slide has the converse of the base angles theorem. And if you remember, a converse is where we switch the order of the if-then statement. So the converse of the base angles theorem states that if two angles of a triangle are congruent, then the sides opposite those angles will also be congruent. So here in this picture, we're given that angle C and angle B are congruent. So then I can conclude that the sides opposite to them, so side AB and AC, will also be congruent. The next slide, we have two corollaries. And remember, a corollary is based off of a theorem. So the first one is the corollary to the base angles theorem. And this one just states that if a triangle is equilateral, then it's also equiangular. And then the corollary to the converse of the base angles theorem states that if a triangle is equiangular, then it's also equilateral. So basically, they're saying the same thing, but in reverse order. And these are all based on those two theorems. Now we're going to do some examples using the information we just covered. Let's do our first three examples here. So for the first picture, in all three pictures, they want us to find the value of x. So let me zoom in here to A. Notice in my picture here, I have some sides that are marked as congruent. So now I can use my base angles theorem and also figure out that these two angles that are opposite those two congruent sides are also going to be congruent. So I can also show that both of these are going to be the same measure. So if this one's x, so is this one. So in order to figure out what x is, I could use my triangle sum, and I can take 180, subtract 30, And that leaves me 150 degrees for the other two angles. And notice they're both congruent angles. So I'm going to take that 150 and divide it by 2, telling me that each angle here is going to be 75 degrees. Now, if it just asks you to find the value of x, we don't need to set up any algebra. We could have just done the calculations. If you would have been asked for an algebraic equation, then what we could have set up is x plus 30 equals 180. Combine our like terms, get 2x, rewrite the rest of the problem, and now begin solving. So we would subtract 30. We get 2x equals 150. Divide by 2, and x equals 75. So if you're asked for an algebraic equation, that's what you would have done. If it just said find x, then just do the calculations. So example B here, we're still finding x. Notice I've got two angles that are marked with congruency marks. What I'm going to use here is my base angles converse. If I have congruent base angles, then the sides opposite those congruent base angles would be two congruent sides. So I can say that 2x minus 4 is going to be equal to x plus 5. This extra 2x plus 2 is just extra information, probably put there to confuse you. If they ask you to find the perimeter of the triangle, then we would have had to go back and use it. But in order to find the value of x, I just needed to use the two congruent sides using my base angles converse. So I'm going to go ahead and subtract x from both sides. And I get x minus 4 equals 5. Add 4, and x equals 9. And then the last one, if you first take a glance at it, you're like, wait a minute, there aren't any same numbers here. How could this be an isosceles or an equilateral triangle? But what we can do first is find that missing angle measure. So we're going to use our triangle sum. We're going to add up the two angles that they gave us and subtract it from 180. So I'm going to add 56 plus 62. I get 118. I need to subtract that from 180, and I get 62. So my missing angle up here is 62 degrees. Notice now I have two congruent base angles. So now I can use my base angles converse, and I can show that these two angles that are opposite, or the two sides opposite the congruent base angles, these would also be two congruent sides. So if the one side is 42, then the other congruent side, which is x, is also 42. So for this one, example 2, it wants us to take the statements that they've given us and put them into a proof and put them in the correct order and then come up with the reasons. Now, right here is what we're trying to prove. This is our given and our proof statement. So I'm going to go ahead and set up my two columns. So I'm going to make my statement column and then my reasons column. Again, your first statement should be the given, which is angle 1 is congruent to angle 2, and that is given to me. So I'm using this last one here, D. This is statement number 1. So I'm going to go ahead and label my picture, and I can put in congruency marks on angle 1 being congruent to angle 2. The next thing that I can see here is that I've got two pairs of congruent vertical angles. So notice you've got angle 1 and angle 3, which are vertical, and also 4 and 2, which are vertical. So that's going to be my next statement, which is this B1. This is going to be statement number 2. I can state that angle 2 is congruent to angle 4 and angle 3 is congruent to angle 1. And this reason is my vertical angles congruence theorem. Because I use this theorem so much, I've come up with an acronym for it. If you'd rather write out the words vertical angles congruence theorem, you can, but the abbreviation I will recognize is VAT. The next thing that I'm going to do is I'm going to use those 3 statements that are in my proof, and I'm going to use a substitution. Now, I'm actually doing like a double substitution here, because what I'm going to do is I'm going to take what angle 2 equals, which is angle 1, because the first statement, angle 1 equals angle 2. So what I'm going to do is I'm going to take angle 1, and I'm going to put it there. So I could say that this is really angle 1 now. And then if you notice, angle 1 congruent to angle 4, then what I can do is take the 4 and substitute it here because I'm replacing this 1 with the 4. So then my next statement is going to be that angle 3 is congruent to angle 4, because what I did was I took out this 1 and I replaced it with a 4. So my next statement is going to be this one. This will be statement number 3. Angle 3 is congruent to angle 4, and this was a substitution. So notice I already marked it in my pictures. And now if you think about it, angles 3 and 4, those are base angles of my triangle. So by my base angles converse, I can now state that these sides that are opposite to 3 and 4, OJ and OK, are now congruent sides. So that'll be my statement number 4, that OK is congruent to OJ, and that reason is the base angles converse. And your proof is done. Okay, example 3. Again, they're asking us to prove, so we're going to write our 2-column proof. Let me set up my statements and my reasons. More than likely, you will have 2 proofs on your test because there's so many different shortcuts we're going to be covering. So I'm going to go ahead and put in my given first, that M is a midpoint, and I'm going to abbreviate midpoint as MIDPT of AB, and that the measure, I'm going to just change this to be angle 1 congruent to angle 2. Let me just simplify it. And that was given to me. Now I'm going to go ahead and label my picture. So angle 1 and angle 2 are congruent, and M is the midpoint. Well, back in chapter 1, we learned that a midpoint is going to be right in the middle of our segment, and it breaks it into 2 congruent pieces. So this tells me that AM is going to be congruent to MB. So it's not listed. I need to list that now as a statement in my proof, and I'm going to state that MB is congruent to MA, and the reason why I can state this is definition of a midpoint. Now that I have 2 congruent angles, angles 1 and 2, I can now state that those 2 sides that are opposite to my base angles are also congruent. So now I could state that AC here is going to be congruent to MA. So that'll be my next statement. AC congruent to MA. And this is my base angles converse again. Since I have congruent base angles, I can show that the sides are congruent. So base angles converse. And now I can use my transitive and I can state what I was asked to prove, that AC is congruent to MB. Because notice what up here is happening. Here is MA, and MA is equal or congruent to MB, so that's what I'm replacing MA with, is the MB. So this would have been either transitive or substitution.